Hello, I'm Art Davis, and this is my review of the MakerFront i3PRO 3D printer. The printer is based on a Prusa i3 open source design. It's a pretty popular platform, and you can read all about it. A good place to get started online would be at the RepRap wiki. If you go to reprap.org/wiki/i3, there'll be plenty of information there, including information for sourcing the parts and building one from scratch if you really wanted. Because it's a popular platform, there's lots of online documentation and plenty of 3D parts that you can download and print and make your own customizations. It's quite nicely suited for modification and customization. I made a number of customizations myself, which I'll review in a little bit. The nice thing though, by going with the kit instead of having to build it from scratch yourself, is that you save a lot of time and even money trying to source all the parts. Basically, you order the kit and what you get are all the parts, steel, laser cut, powder coated frame components, all of the hardware, the electronics, step-by-step instructions, a custom built firmware image, and you get support from MakerFront. So the kit really is it's the most cost-effective way and really the fastest way to get yourself 3D printing with a printer you can say that you built yourself. Let's take a look at the construction. So the frame of the printer is made out of 1/8 inch laser cut powder coated steel. Makes the whole printer solid, really stable. You can dial it in and it'll pretty much just keep on printing without need for making any kind of adjustment. You can move it around, tip it up and down, even bump it while it's printing and it'll be fine. Not recommended to bump it while it's printing, but just saying. You've got easy access to everything. It's a nice open design. You can get down here, we got power supply coming around over the other side. Here we got all the board electronics and wiring. Now that is one of the downsides. Wiring is real tough to handle with an open design like this. What do you do with all the wires? You got to get them where they need to go. So one thing you should do is get some of this wire wrap material. It's pretty easy to find online. It comes with some when you order the kit, but you could just never have enough of this stuff. And it's really nice for tidying up all the wires as best as you can. You probably get maybe 3mm and 8mm or a couple of good size wire wrap to use. Also, the whole thing is pretty much put together with these M3 screws. So do yourself a favor and get yourself a decent ball drive M3 hex key. Pretty much put the whole thing together with this. And having the ball drive, there you can see it, lets you get in and use all sorts of different angles in order to torque the screws in and tighten them properly. Alright, let's get into some of the customizations I've done to my printer. First thing here, let me just tip it up. Take a look at the bed from underneath. Alright. Oh. Stay there. Don't fall. Cool. Alright, so let's see if I can zoom in on it here. And you've got 4 of these, one in each corner. 1, 2, 3, 4. And getting a wrench on all of those nylocks can be quite a pain. It's much more convenient if you could just adjust the bed level with a hex wrench and not have to worry about getting a wrench on the nylocks. So if you print out these little nylock capture brackets here, which interlock with the bed frame brackets so that they never ever fall out, then all you ever need to do is use the hex key. Oh, it makes leveling the bed so much more convenient and easy. I found these bed nut holders on Thingiverse, number 946566. You can go up there, grab them, print them, use them for yourself. Another thing that you can get away without doing, but I kind of like this modification. I actually ran without this modification for a long time, but after my rods and my bearings started to get worn in a bit, my platen started to bind up. So what you can do, notice we've got 1, 2 back there, 3, and over here is a place for a 4th bearing. Instead of putting that 4th bearing on, I just leave it out. So I run with 3 bearings because 4 is a little bit over constrained and you could get some binding. So feel free to just leave out one of those bearings and run with 3 linear bearings in the y-axis. Runs just fine. I'm quite happy running it like that. Back up top here on the platen, this is definitely not your stock platen. You do need to get your own 8" by 8" piece of glass, and the standard directions are to use some binder clips to clip the glass down between the heated PC board and the glass. Now the thing about that is that you just have to be careful that you don't bash those binder clips with the nozzle or any other crazy modifications that you might happen to make to the print head like I've got here. But basically what I custom designed was this quick change platen, which is just a couple of L-shaped brackets and then these little plastic eccentric discs, so that in order to take the glass out, all you gotta do is rotate the discs out of the way, pull the glass up, put the glass back down, rotate the disc back in, and you're good to go. Actually quite a bit faster and more convenient than taking off 4 clips, and it holds the bed in nice and secure. There's never any problems with the bed moving around or getting pulled up during the print. If you're interested in this print bracket, I've got it up on Thingiverse, Thingiverse item number 1109037. And then another customization I did back here is, since I've been messing around with different heated bed platforms, I put some connectors in so that you can quickly just disconnect the heated bed, put in the next heated bed, and not have to undo the wire wrap all the way back to the PC board. Now a comment about the Z-axis drive system. The Z-axis goes up and down using these threaded rods on these motors over here. It drives the head up and down. Now apparently getting threaded rods that are perfectly straight is actually pretty difficult. So it's not unusual, you may wind up, as I did, getting slightly warped threaded rods, which really isn't a problem, except that up here where the rod protrudes through the bracket, it can rub up against the metal and make a pretty obnoxious squeaking noise. So what I did was I designed these bushings that you can print out and put them in there. They're just little plastic bushings that pop in this hole, and then the threaded rod will rub up against the plastic and be nice and quiet. Won't have any problem. I've got those bushings up on Thingiverse thing number 892252. Over on this side we have our Z-axis adjustment screw. And what happens is there is a little limit switch which is going to come down and hit the top of this screw, and that sets the 0 for your print head when it comes down onto the platen. Now the stock design, you just have this regular long, it's about 50 millimeters or so, maybe 60 millimeter screw that you put down into this nut. Now the problem is that when the head comes down, hits the top of the nut, and the nylac screw can be quite rigid, and in order to actually turn this screw and adjust the Z-axis 0, you have to bring the Z-axis up enough in order to fit your hex key wrench in there. So a small modification I made, which is quite convenient, is I got a M3 wing nut, actually an M3 wing nut bolt that goes up through the bottom, and then I couple it into this M3 standoff, and then I put like another 15-20 millimeter M3 bolt here. I think it's going to come down and hit that stop right now. There it goes. It's going to back off a little bit and come down a little bit slower. And that's at 0. So if I didn't have this wing nut in there and I wanted to adjust the Z height, I'd have to line it back up, maybe at least another 10 or 15 millimeters, just enough to get my hex key in there, and then I could come back down. As you can see, the Z axis is pretty slow, so that can be time consuming and frustrating. So now with the wing nut, I want to adjust the Z height. I turn it that way in order to bring it. Which way did I turn it? I just backed it out, so I would have made the Z height 0 down lower. I want to go the other way. I turn it the other way a little bit. So this way, I have very fine-grained control of the Z-axis 0 height location, and it's very convenient. In the back, we have the Y-axis limit switch. Let's zoom in on that a bit. All right, you can kind of see that little rocker right there. Let me get my pointer in there. All right, so when the bed platen comes back and pushes that rocker in, boom. All right, that's how we know we've hit limit of travel in the Y-axis. All right, let me just do that real quick and drive it home. Hit the home button, XY. There it goes. All right, the platen's gonna get in the way. I can't see it, and just bash into it. But it is a common thing to do. In fact, every print, and pretty much whenever you want to start doing anything, you home the X and the Y axes. So that limit switch is getting bashed into a lot. Now the stock construction only has one screw which goes through this limit switch PC board and through the Y-axis mounting bracket. So after you bash that switch a couple of times with the platen, it tends to start falling over. So what I've done is I've designed this little bracket here to sit inside of this Y-axis end stop bracket, and that holds that PC board perfectly straight every time. So that's just a nice little addition, modification you can make. I've uploaded that bracket up to Thingiverse. Its thing number is 897019. Now probably one of the most obvious modifications here, it's sort of ungainly. and probably will try to update it with some smaller fans in the future. But currently I've got this massive cooling system with 2 separate fans with these shrouds directed right at the output of the extruder. So what this does is it provides a nice laminar airflow onto the plastic as it is extruded, and what that does is it helps freeze the plastic as quickly as possible as the print progresses, and that can help with print quality. It helps me run the printer quite a bit faster because I don't have to wait for the plastic to freeze. It freezes very quickly, and it's also quite helpful for bridging, so I can bridge pretty decent expanses using this setup. This whole cooling fan assembly, which includes this MK8 bracket, adjustable sliders for the fans, the fan brackets for custom size fans, and the shrouds in order to direct the air. Those are all available on Thingiverse. I put them up on Thingiverse thing number 1046948. Now, especially when I was doing this cooling fan project, and in general, I'm messing around with my extruder, so I'm trying to take the whole thing off and put it on, and take it off, put it on, and that can get pretty tiresome, having to unwrap all the wires all the way back to the control board every time. So another little hack I did was I just added some extra connectors here. Well, for the fans I just used some fan connectors, so I can just unplug those, and then for the thermistor and the heater, I've added these extra connectors here, so I can basically disconnect the thermistor, disconnect the hot end, and disconnect the fans, and I don't have to unwrap any of the wire wrap, and I can take the whole extruder head off and mess around with it or put a different one on. Now, MakerFront does provide a build of the Marlin firmware, so all of the settings are optimized for this printer, so you can upload that onto your Arduino. There is an Arduino back there, actually, underneath all those wires, and actually it's behind the ramps board. I bought this smart controller as a separate add-on. It's not part of the stock kit, but it is nifty. You've got a full graphic display, and you can run through various menus and control your printer using it. And there's various add-ons, so you can see the percentage of your print complete. You got real-time monitoring of your hot end temperature, set point, actual temperature, and your hot bed, your heated bed, set point, and actual temperature. If you do one thing, do this: get yourself a Raspberry Pi and install OctoPi on it, which runs the Octoprint server, which basically makes your 3D printer into a standalone network printer that you can batch off print jobs to. It'll communicate directly with your slicer program, can upload your sliced STLs right to the Raspberry Pi from a web page, and it'll print happily along. You can turn your computer off, and it's just a much more convenient way to use your 3D printer. Now, here I've got my Raspberry Pi 2. Of course, I had to print out a nifty case for it. And then another nice add-on to do is to get this Raspberry Pi camera. And what that allows you to do is to monitor your print from the Octoprint webpage. So, for example, over here, and by the way, this is just a video cable connected right to the Raspberry Pi. So I'm looking at a web page on the Raspberry Pi. it's the web browser is just browsing to localhost, but I could pop this up on any computer in my network. And for example, I've got all these different handy controls here. Over here on the left hand side, I've got all my files that are currently uploaded. I could hit print at any time. Currently I got real-time monitoring of the temperature. I can set the temperature and of the hot end and of the bed, of course, and then I can do full XYZ control, and I can mess with the extruder and home, of course. And well, what's this up here? It is the video live feed from the Raspberry Pi camera in the web page. So that is super convenient. Nifty enough. You can go into time lapse and then take pictures at set intervals and make a nice time lapse video of your print. So being available on the web also, well, I should say my local area network, means that I can use my phone to control it as well. So I go here to printer control, and you know, right here, hit the play button. Now I have live feed on my phone of what this Raspberry Pi camera is seeing. Let's see my Raspberry Pi camera. Look at the phone. Whoa, whoa. All right, so that's pretty cool. And then I actually use this all the time. This is what I use as my primary control for my printer, quite honestly. Especially when you're leveling the bed, it's pretty handy. So I'm gonna set my step size, and then I can hit the button, move to flatten, Y, X. Of course, I can home it. Yeah, cool. So move it around, and then in Z. You want to make sure that you, when you start messing with the Z-axis here, you can have it say on 110.1 or 0.1. If you accidentally leave it on 100 and then press one of the Z-axis buttons, it'll dutifully go ahead and try to move your Z-axis 100 millimeters, which takes way too long. So always try to make sure it's only at 1 millimeters, maybe 10 millimeters for moving the Z-axis around. Very cool. Power-wise, the Arduino and even the smart controller will come up if you just plug it into USB power. So either like a phone adapter, USB charger, or just a USB port on your computer, and the printer brains will fire up. Of course, you can't drive the motors or use any of the heaters unless you plug it into wall power. So over here, I got the power cord for the printer plugged into a kilowatt. Sitting idle, it draws about 6 watts parasitic voltage, just sitting there eating up 6 watts doing nothing. When you are actually running a print and the heater's running and the heated bed is on and you're extruding plastic and you're driving the motors, it'll climb to around 200 watts. But if you do want to shut it off while it's just sitting here plugged in, there's no actual off switch. So one thing you can do is, if you just plug it into a power strip, you can hit the switch on your power strip, or you can get one of these handy dandy socket switches, which I got, and you just turn it off, and then that'll save some power while it's sitting idle. Alright, looks like the first layer is about to finish up here. Since we ran it nice and slow, we got good quality first layer print. And once that's done, we'll move on to the second layer, and then we can really fly. Basically crank up the speed to between 50 and 100 millimeters per second, depending on whether it's an outer perimeter, inner perimeter, or infill. There's the inner perimeter. Now slowed down a little bit to the outer perimeter. And now it's just putting down the infill of the second layer. This is going much faster. Alright, now we see the printer is doing some bridging. So it just ran at a high speed between the corner pillars of this bin box, and then it's going over the top of it with a couple of extra layers. And you can see we can make these rectangular bridges essentially without any support underneath. Having the extra airflow blowing on the nozzle like this really helps with the bridging. That's all I've got. If you want to see some projects that I've done with the 3D printer, check out my page at thingiverse.com/artdavis. Thanks.